Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in today's session we are going to dive deeper into the Poisson distribution, one of the most fascinating and practical concepts in probability. In previous video I discussed the basics, what Poisson distribution along with its mean, variance, skewness and kurtosis. If you haven't watched yet, I highly recommend checking it out first. Now in this video, I will focus on solve numerical problems that show how Poisson distribution works in real world scenarios like traffic arrivals, medical reactions and reliability of systems. You will learn how to calculate probabilities step by step using the Poisson formula. So without further delay, let's get started. So first example, the number of heavy trucks arriving at a railway station follows a Poisson distribution, and the average of arrivals during a special period of 1 hour is 2. So we will remember this one. Basically this is lambda. Now find the probability that during a given hour no heavy truck arrives, at least 2 trucks arrive. So here, as I have told you, this is the value of lambda and we will use to solve these two problems. So here the average number of truck arrivals is 2, that is the value of lambda, and let x be the number of trucks arriving in a given hour, and the Poisson probability mass function, that is e raised minus lambda, lambda raised x upon factorial x, where x varies from 0, 1, 2, 3 and so on. Now we will use these concepts to solve the problem. So when no trucks arrive, that means x has value 0 for no heavy truck. So we will put it. So when x is equal to 0, so here we have value of lambda 2 and here 2, but value of x is 0. So factorial 0 here and 2 raised because x, so that is 0. So we will get e raised minus 2. This is the probability that no heavy truck, and finally it would be 0.1353. Second one, probability of at least 2 trucks. So at least 2 truck means from 2 to onwards. It may be 2, 3, 4, but at least 2. So probability of x, that is greater than or equal to 2. So here we can also write this expression like this one. xp, probability of x, that is greater than or equal to 2, and this one x is equal to 0 and 1, that is a complement of this one. So just you are subtracting, so you will get x, that is greater than or equal to, we will get the probability. So we will find out the probability when x is 0 and when x is equal to 1. So here x is equal to 0 we have already calculated. We will find out the probability when x is equal to 1. So here when x is equal to 1, so e raised lambda, so that is minus lambda, so that is minus 2, and 2 raised x, that is 1, and factorial x 1. So we will get the value 0.2706. Now we will plug these two values here and here. So let us plug and we will get 0.5941. Let us see example 2. So if the probability that an individual suffers a bad reaction from an injection of a serum is 0.001. So find the probability that out of 1500 individuals, exactly 3 more than 2 suffer a bad reaction. So let us solve it. So first of all, solution setup. So what is the random variable here? So let x be the Poisson variate that representing the number of individuals suffering from a bad reaction. So there were two questions, but before that, here n 1500 p 0.001, and we know that lambda is equal to np, where p is very small and the value of n is very high. So that means little bit concept of binomial distribution here. So we will have lambda is equal to 1.5, and we will use this value to solve the problem. So again, Poisson distribution, e raised minus lambda, lambda raised x upon factorial x, where x is from 0, 1, 2 and so on. So probability that exactly 3 suffer here. So x is equal to 3. So we will plug lambda value 1.5 and x 1.3 raise x, that means 3, and here factorial x. So we will calculate this expression and we will get 0.1255. Now probability that more than 2 suffer. So more than 2, that means x is greater than 2. We can also write this one, 1 minus p, x is less than or equal to 2. So we will plug these values because we have already calculated. So let us calculate it again. So we can calculate in this way. Lambda is always 1.5. Here x 1 0, x 1 and x 2. And after calculating, we will plug here and we will get here 0.1903. Now let us see moments of Poisson distribution. So if the mean of a Poisson distribution is 1.44, so find the variance, the central moments of order 3 and 4. So let us see. So here mean means lambda, we have 1.44. Now we know that the variance and mean both are equal for a Poisson distribution. So variance is also 1.44. Central moment of order 3, that is also lambda. Order 4, that is basically 3 lambda square plus lambda. And if we plug the value, so we will get 7.66. Just you need to plug the value of lambda. Now it is given that probability condition. What we need to do, we will solve it for lambda. That means p, the value of x when it is 1. So this is also equal to 2p for the value of x, that is equal to 2. So we will find out the mean and variance also. And because lambda is mean and variance, so the same. Let lambda be the mean. So Poisson probability mass function, I have already discussed many times, e raised minus lambda, lambda raised x upon x, where x varies from 0, 1, 2. So we will find out px is equal to 1. So we will get in the left side p, and this one is 2 into here px is equal to 2, and we will equate. So we will have this equation, and thereafter when we solve it, so we will get lambda minus 1 is equal to 0. So from the equation we will get lambda is equal to 0 or lambda is equal to 1. But lambda is equal to is not 0 because it implies there is no distribution. So lambda is equal to 1. Let us see the next question. Near lambda is equal to 1, so mean 1, variance 1. Let us see the question number 5. Sum of two Poisson variables. One is the following Poisson 1 here. So we can say that this is the lambda 1 and this is the lambda 2. And both are independent. So we need to find out p x plus y, that is less than 2. So we know that the sum will follow x plus y, that will follow Poisson distribution with their sum of lambda, that's 3. So we will solve for this one. So basically PW is equal to W, and here we have assumed that W is equal to X plus Y. Then we'll just plug the value here. So W is equal to 0 and W is equal to 1. We will add it and we will find out the value. Thereafter we will just keep it here, plug it, and finally we will get 0.1992. Now example number 6. The probability that an individual coal miner is killed in a mine that was accident during a year, that is 1 upon 1400. So in a particular mine there are 350 miners. So what is the probability that at least one fatal accident will occur in a year? So again you will find the probability. P is given. So here n is also given. So lambda is np. Always remember, if p is given and numbers given, so you will find lambda in this way. You will multiply them, where you will observe that n is very large and p is small. That's why it is applied where accident, arrival after long time. So where it is applied. Now we want to find 1 minus p, x is equal to 0. So we will have, because x is equal to 0, lambda we already know 0.25. So we will plug and we will get 0.2212. So there are 22.1% chance of at least one fatal accident in a year. So this is what we wanted to calculate. Now the question number 7, Poisson distribution validity check. So it is given that mean and standard deviation of a Poisson distribution are 6 and 2 respectively. Test the validity of this statement. So here see that very simple. We know that for a Poisson distribution mean and variance are equal. So here mean 6, lambda 6, but standard deviation given 2, so variance would be 4. So lambda is equal to 4, and that is the variance. But two different values of lambda, which is not possible. So the statement is invalid. Now example number 8 and the last example. For a Poisson distribution, it is given that p x is equal to 1, that is equal to x is equal to 2. So find the mean of the distribution. So basically also find p x is equal to 0 and p x is equal to 4. So let us see. So let lambda be the mean of the distribution, as always. And the Poisson probability mass function is E minus lambda raised x upon factorial x. So we will find p x is equal to 1. Basically we will equate. So here this equation is here and this one is there, and already it is given. So we will equate and we will find the value of lambda. So here lambda square minus 2 lambda is equal to 0. So lambda is equal to either 2 or 0. So we will take lambda is equal to 2 and we will reject lambda is equal to 0. So mean is equal to 2. So here lambda we have got. So px is equal to 0 we can find, because it will require lambda. So here minus 2 x 0. So first step is to find lambda. Thereafter we can find probability for any values of x. So it is 0.1353 for x is equal to 0. Now second was for a 4. So instead of 0, you will plug here 4 at the place of x. So we will have 0.0902. So hope you understood. For more resources, you can visit www.postnetwork.co like quiz, PDF, video and post. You can visit YouTube channel, and you should subscribe to support. Facebook page you can visit, and you can also connect to LinkedIn page. And for a code, you can visit GitHub repositories. So hope you understood. Thanks for watching the video.